Yo, what is up, YouTube? Today I'm going to be going over sort list. It's a medium LeetCode problem asked by Amazon. If you guys haven't already, check out my channel. I post these videos every weekday, and I'll see you guys soon. Okay, so now we have sort a linked list in O of n log n time using constant space complexity. So why is it doing that? Oh. So we constant space complexity, so we can't, that means in place we can't create a new linked list. And O of n log n, that should give you a hint that we need to use merge sort, because merge sort is log n space complexity, and or not space, runtime, sorry, and then we have to do it n times, call the function n times. So yeah, we just have to sort a linked list. The fact that it's a linked list data structure just makes it a little different, maybe a little bit harder. So I just wanted to go over merge sort on the whiteboard. So we have merge sort here. So if this is our list, I just wrote a bunch of random numbers. It's 8 numbers, 1 through 8. So as you guys know, merge sort's recursive. Technically, it could be iterative as well, but it's typically used as recursion. So it's just going to split the list in half. So it's going to do the left half first, and then it's going to split that one again. So the first call, it's going to call the left half, and then it's going to split it again, and then it's going to split it again until it's all like single numbers. And then we're going to, when we merge them, so the first part is the partitioning, which we just went over, which is splitting it. And then on the way back up, we're going to merge them, but in sorted order. So this is going to be 6, 8, and this is going to be 1, 5, and this is going to be 1, 5, 6, 8. And then it's, I don't want to write this one out too. It's going to be sorted. This side's going to be sorted. Same thing. And then we just merge those two lists, and they're going to be in order. So that's how we're going to solve this. So there's going to be a lot of little nuances that we run into. So let's just start. So if head equals null, or head dot next equals null, we're just going to return null. So we actually need that. Actually, it's not null. Is it null? I think, I don't know, we'll figure it out. Oh, sorry guys. Be right back, this is important text. Alright, so sorry I had to take that phone. Text was important. Anyways, so what we want to do is we want to split the lists in half, but that's not really easy because it's a linked list. So we want to be able to set a tail here, a head here, and a tail here, and a head here, and a tail here. So we could do that by doing, well, head's already here, so we already have a head. So we could do a slow and move it 1 at a time, and do a fast, which moves 2 at a time. And as soon as fast.next equals null, then we're done. So let's do that. Sorry, I'm like thinking about it in my head as I'm doing this video, and we just want a tail for the left half. So they're all going to be equal to head and fast.next does not equal null. And you know what, I just realized this is supposed to be head. Why we're not, we have to return the list node. So, and this didn't indent. So we're going to set tail equal to slow, because this is going to be the tail, and then we're going to increment slow, so it's going to be the head of the right half, and fast equals fast dot next. So what that's doing is fast is going like this. So fast is here, fast slow is going to be here, and tails here, and then the second iteration, tails here, fast is going to be over here. It's going to be null. So that's the tail. We want the tail to be null. So we also have to remember to set a tail null for the left half. And where was I going? Oh, and so slow is going to be the head of the right half. So, yeah. So now we just need to set tail.next equal to null, because we need the it to have like an end. So otherwise, the head is just pointing to the whole list still. We just need to do the recursive merge sort calls. So list node left equals merge sort, and we're going to do so left is head and slow, and list node right is merge sort. It's going to be, no, this is not right. This is supposed to be tail. Sorry, guys. I probably should have named them better. Tail, or slow and fast. Okay, so now we have everything set up correctly. We just want to return, no, it's not merge sort, it's sort list. So this is, we're recursively calling sort list. This is sorting it into halves. It's just going to keep breaking them in halves. I don't want to draw out the recursion stack. That'll just take way too long. I'm already at like a 6-minute video. So, and then we want to do merge sort. So this is where we merge. I'm just going to call it merge. Left and right. Okay, so let's do list node merge list node left and list node right. Okay, so now we have to merge them. We need to create a list that we're going to return. So list node merged equals new list node. So let's start it at the beginning. So we can return dot next, and it'll be pointing to the head. And if we do a current node equals merged, that's pointing to, it's pointing to that. But then now we can set current dot next to the first node. So if left dot, or no, let's do, it's while left it does not equal null, and right does not equal null. Yeah, that's correct. If left dot val is less than right dot val, then current node dot next equals left. So that's just setting, since current node's pointing to 0, we want to do dot next, so we're at the head, and if left is less than right, we want to put left at the beginning. It's not always going to be the beginning, it depends where we are in the while list. and we need to increment, move the pointer for the left, and so this is just if they're equal or right dot val is less than left dot val. So we do the same thing. And up here we could have done current equals current dot next, but I'm going to do it outside. We need to remember to move the pointer along in the current list. Current node equals current. Okay. Hopefully that makes sense. And so this one's just the opposite, right equals. I'm sure you guys have done stuff like this. And typing too fast. Okay, so now if left does not equal null, then we want to current node dot next equals left. Else, which means if right is not equal null, current no, because one's always gonna be empty before the other one. And I think that's it. And then we just want to return merge.next because merge is still pointing right before the head. So return merged dot next, and I'm sure I made an error in here, so let's debug it now. Expected oh wow, I just put or. That is dumb. Short list. Oh okay. So we just need to pass the head. So this is just head, and this is just slow. I was writing it out for merge, the merge function. Okay, sweet. So that I did do that right. All right, that wasn't bad. That was just a few syntax errors. Okay, so this is O of n runtime, because we're just no, it's O n log n because we're using merge sort. We already went over that in the beginning. And space complexity, this is O1, so this is just constant, because we didn't need to create a new linked list. We created a pointer to the linked list. So yeah, that's how that works. If you guys have any questions, let me know. I like to answer your questions, and if this video helped, let me know. Hit that like button, and I'll see you in the next one.